Hi, this is Ganesh Shilgati. Today I am going to discuss about estimation and hypothesis. Firstly, what is meant by hypothesis? Hypothesis is a process of checking the given condition accepted or rejected. For example, it is given that all age of boys in a class are equal. We have to check this given condition is accepted or rejected by using hypothesis test. While talking about hypothesis, there are two types of hypothesis. One is null hypothesis. Second one, alternate hypothesis. Coming to null hypothesis, it states that there is no difference between groups or relationship between variables, which is denoted by h naught equals mu equals to mu 2. Coming to alternate hypothesis, it is complement to null hypothesis, which is represented as h1, whereas mu not equal to mu. By the null hypothesis, it subjects to two errors, type 1 error and type 2 error. What is meant by type 1 error and type 2 error? Type 1 error are subjected that if the null hypothesis h naught is true, but it's still rejected. But still it reject. H naught null hypothesis where it is true, but it's subjected to false or rejected. Coming to type 2 error, here h naught is false, but it is accepted. Which is represented as false, but it is also accepted. Now coming to testing of hypothesis. There are various types of testing of hypothesis. First one, student t test. Second one, f test. Third one, chi-square test. In student t test, there are three methods. First one, single mean. Second one, difference between means, difference of means. And third one, paired t test. While coming to chi-square, there are two methods. One is goodness of fit, and second one is independence of attributes. Now try to solve student t-test hypothesis. We'll discuss about single mean t-test. Let us start with procedure. First step, null hypothesis, where mu equals to mu naught. And step 2, alternate hypothesis, where mu naught equals to mu naught. It is an two-tailed test. Mu greater than mu naught or mu less than mu naught, which is one-tailed test. While talking about two-tailed, one-tailed, let us consider it as normal distribution. If both sides are rejected, Those are rejected areas, which is two-tailed. The values between rejection area known as critical values. Coming to one tail, rejection, if mu less than mu naught, if mu greater than mu naught. Those are one tailed. Coming to step 3, level of significance, which is represented as alpha, like level of significance 1%, 2%, 5%. Next, degree of freedom, which equals to n minus 1. Now, coming to step 4, test statistics. T calculated value, which is represented as x bar minus mu by s under root n minus 1. Here, x bar equals to mean of sample, mu equals to mean of population, s equal to standard deviation, n equal to number of samples. Now coming to conclusion, T tabulated value equals to T for my alpha comma degree of freedom. If T calculated value less than T tab value, then H naught is accepted. If T calculated value greater than T tab value, then H naught is rejected. This is a process of find outing single mean t-test. Here, a random sample of 10 boys had the following IQs 70, 120, 110, 101, 80, 30, 83, 95, 98, 107, 100. Does this data support assumption of the population mean of IQ of 100? Find the reasonable range in which the most of the IQ levels of the sample of 10 boys. Here, sample size n equals to 10, and those are IQs, and we have to find the reasonable range, which is confidence limit, which equals to x bar plus or minus t tabular value into standard deviation by root n, and we have to prove it is significant or not. First, let us find x bar value. X bar equals to summation of x by n. X values are 70 plus 120 plus 110 plus 101, so on. 100 by n value as 10, which gives 97.2. X bar value as 97.2. Now let us try to solve standard deviation. S equals to under root of 1 by n minus 1 into summation of x minus x bar whole square. 10 minus 1 into 70 minus 97.2 whole square plus 120 minus 97.2 whole square, so on, plus 100 minus 97.2 whole square, which gives standard deviation as 14.27. While coming to the procedure of simple mean, step 1, null hypothesis, where mu equals to mu naught, and step 2, alternate hypothesis, where mu naught equals to mu naught, which is 2 tail, and alpha value as 5%, because in question it is not given of level of significance. So default level of significance as 5%. Next, degree of freedom, sorry, n minus 1, where n equals to 10, 10 minus 1 equals to 9. Step 4, test statistics. T calculated value, x bar minus mu by s under root n minus 1. From the data we found x bar equals to 97.2 and mu, which is given as 100. Standard deviation we found as 14.27, n equals to 10. By substituting those values, T calculated modulus 97.2 minus 100 by 14.27 by under root 10 minus 1 modulus, we get as 0.58. Now coming to conclusion, T tab value, T level of significance and degree of freedom, which has 0.05, 9. From the T table, two-tail test, whereas at 0.05 and at 9 we get it as 2.262. T tab value as 2.262. Here T calculator value equals to 0.58 and T tab value equals to 2.262, where T calculator value is less than T tab value. Therefore, S naught is accepted. So, it is significant. Now, we have to find the confidence limits, where confidence limits equals to x bar plus or minus T tab value into standard deviation by root 10. X bar as 97.2 plus or minus T tab value as 2.262, standard deviation 14.27 by root 10, which gives as 86.993 comma 107.40. Those are the confidence limits. Now let us try to solve another problem, where a random sample of 16 values, where n equals to 16, from a normal distribution population of mean 53. Sample mean x bar equals to 53 and sum of squares of deviation from the mean equals to 150. Sum of squares of deviation, which is represented as x minus x bar whole square equals to 150. This sample regarded as taken from the population having the mean 56. Population mean mu is equal to 56 and confidence level as 95%. Now let us find the standard deviation value as 1 by n minus 1 summation of x minus x bar whole square, 1 by 16 minus 1 into 150, which is given in the problem, 1 by 15 into 150 tens is equals to square root of 10, which is gives 3.16. Coming to the procedure of simple mean, step 1, null hypothesis, where S naught mu equals to mu naught, and step 2, alternate hypothesis, where mu not equals to mu naught. It is an two-tailed test. Coming to step 3, level of significance is given 95%, which is alpha equals to 0.05. Now degree of freedom equals to n minus 1. Here degree as 16 minus 1 equals to 15. Now step 4, calculated value, test statistics equals to x bar minus mu by standard deviation by under root n minus 1. Here x bar as 53 minus mu as 56 by standard deviation 3.16 by 16 minus 1, which gives 3.67. Now conclusion, t tab value, which is alpha comma degree of freedom equals to 0.05 comma 15. From the t table, it is an two-tailed test at 0.05 to 15, which gives 2.131, which is as 2.131. Here t calculator value, which is greater than t tab value, therefore h naught is rejected. Thank you. In next video we will discuss about difference of means and paired t test.